are going to have your first lab this week. Your uncertainty analysis lab is going to start this week. And I'm sure you know where the lab is. It is room A021A, the basement of 300 Main Street building. There is a yellow room, which is one of the rooms that is adjacent to that room. Just go gather in the yellow room, your TA is going to come and get you. Okay? And you had your first quiz on Friday. As you saw, the quizzes are not very difficult. If you think too much about the quizzes, you'll definitely lose points. Because you had an issue about one of the students had an issue about one of the answers, that there was a confusion about the meaning of a block versus a cube, and that caused the students to lose just half a point. But this is just half a point, so there is nothing to worry about. I'm sure we'll recover from losing half a point. That's it. Do we have any questions? Next week is, I guess, the class. We are going to have two different classes essentially for aero students and NE students. If you are an aerospace student, you are going to come to class on Wednesday, and we will talk about flight mechanics. And if you are a mechanical engineering student, you are going to come to class on Monday. We are going to talk about 3D printing and additive manufacturing. Any questions? So aerospace students, Wednesday. Aerospace engineering students. Who are at the aerospace students? Okay. It's only the aero students come to class then. Sorry. This is a good thing because you're gonna see a lot of me in the future. Actually. Okay. Any questions? This week we're going to talk about the hardness test. This is your second lab. We're going to talk about the hardness of the material, and then our test is going to be essentially measuring the hardness of a metal, and also measuring the hardness of a rubber type material. The first thing you want to know when doing a hardness test, is to know what is hardness. Hardness is the capacity of material to resist any plastic deformation, penetration, indentation, and scratching. So what we're going to do is we're going to test the indentation with a micro hardness tester, the Vickers hardness tester, and for the metals, and we're going to test the resistance to plastic deformation for the rubber-like material. Hardness can be used for material characteristics, and essentially we're going to measure the hardness test, and then we can convert this using empirical equations to yield stress or ultimate stress, and we're going to see the equations for those later on. Okay, we did talk about this. Okay, so for metals, we have two main tests for hardness, measuring the hardness of the material. First is the scratch testing, which is used for brittle material, and then indentation testing, which is used for a little less ductile material. So why do you think we use the scratch testing for brittle material and indentation testing for ductile material?
You try to use the scratch testing or the indentation testing for brittle materials to crack the material.
Great, exactly. They will most likely break. So essentially, if you use the indentation testing, if you try to create an indent in a brittle material, the material will fracture and break eventually. It's not a good idea to use indentation testing for brittle material, and we have to use the scratch testing for brittle materials. Different types of hardness tests are the three of them are shown here. We have the Vickers test. These are the indentation testing. We have the Vickers test, Grinnell test, and the Rothwell test. The difference between all of these tests is the thing you use to create that indentation. For the Vickers, we have a diamond-shaped thing. For the Grinnell, we essentially drop a ball on your ductile material, and for the Rockwell test, we drop a cone on your material, on our material. And what we're going to do with these is we are going to measure the length or the diameter of the indentation that we have created. And based on this list and an equation, we're going to measure the hardness of that material. For us, we are only going to use the Vickers test. And this is the device we're going to use. It's called the micro Vickers micro hardness test. You're going to put your sample right here, and then it has an indentation like this module. You determine the force that you want to use in your indentation. For this experiment, we're going to use I think 100 grams of force. It's either 100 or 1,000. It is in your lab instruction, which is already uploaded. And then you create the indent. You change it to a microscope. You rotate this module to a microscope, and you see the indent. There's also a measuring device right here. You're going to see two lines essentially when you look at the microscope. And using these two lines, you can measure this. These two lengths essentially, and using these two lengths, you're going to measure the hardness of the material. So Vickers test. Different types of tester, the Brunel tester, Rockwell tester. When you go to the lab, all of these testers are there, but we are only going to use the Vickers hardness tester, which you have to. This is what you're going to see when you create the indentation. So this is your indentation that you have created. This is your material. And these are the lines you're going to see in the microscope. You just have to move these lines, and then there is a gauge outside. Using that gauge, you're going to measure the line. One thing you have to do, and this is because you're doing an experimental measurement, essentially means that you have to do a statistical analysis, is that you have to measure this length and this length, and then use an average, I guess, right? These two lengths might be different. They are not supposed to be different theoretically, but they might be different. One thing you need to do before doing the experiment is to make sure that you have a very polished surface. Because if it's not polished, you may not be able to see the indentation that you have created. Okay. Let's move on. So what is the equation we're going to use to calculate the hardness of the material? For different methods, we have this table with the Brunel method, Vickers method, Knoop method, and the Rockwell method. The equations is given to us right here, right? But as I said, we are only going to use the Vickers test, which uses a diamond pyramid, right? For this test, just have to have the load and a correction factor and the length of the indentation that you have created. Using these, you can measure the hardness of the material. Of course, you have to create a couple of indentations, not just one. Because at the end of the day, again, you're doing an experimental measurement. You have to calculate and measure the uncertainty of the hardness of the material. So essentially, you create 5 indentations, 3 indentations, and then you have to share the data with each other in your groups. Then eventually measure the uncertainty of the material. One thing you have to be mindful of are the units that goes into that equation. The units of force is kilograms of force or grams of force. We are going to put either 0.1 kilograms of force or 1 kilograms of force. The units for length are the millimeters. So the hardness you calculate is in kilograms of force per square millimeters. Yeah. You can convert the hardness values to each other, and let's actually see these. So when you have the hardnesses, one of the things you can do with the hardness value of any material is to use these correlations to find the yield stress and the ultimate tensile stress. Hardness itself is not a physical property of the material. It's essentially something that we have defined for the material, and using this value, we can can find a lot of different things that can be physical properties of the material, like the yield stress and the ultimate tensile stress. Okay, let's move on. Part 2 of the experiment is the measurement of hardness for a rubber-like material. The problem with the rubbers is that you cannot create an indentation, right? So what do? We essentially use we try to measure the resistance to plastic deformation using this device that is called a durometer. So when you have this durometer, you see this pin here, the small pin. Just have to put the pin on the rubber material and then measure the force, the resistance to the plastic deformation of that specific rubber. You will be given a couple of different rubbers. You just have to do the durometer measurement for them a couple of times. It's a very simple experiment because there is no additional calculations other than the statistical analysis here. The gauge over there is going to, and for us it's a digital gauge, is going to give you the hardness of the material, hardness of the rubber material. You don't really need to do any additional calculations to find the hardness of the material. This is how it works. Essentially just put it on the rubber, the dial here moves, and you read the value of the dial. That is going to be the hardness of this material. We did talk about these things. One thing that you want to do is that you want to make sure that you are making the measurements, especially for the rubber, at least 12 millimeters away from the edges of the rubber material. Why do you think that is? Why do we want to measure 12 millimeters away or some length away from the edge of our rubber material?
There's just going to be more give towards the edges.
There's going to be more give toward them?
Yeah,
It is not going to give you accurate results, exactly. So whenever you're dealing with a boundary of any material, that boundary has its own thing going on. Like for a rubber that is not fixed, you're going to have free movement of the boundary, which essentially will make your measurement very inaccurate. So you want to make sure that you stay away from the edges of the material as much as possible. You make a couple of measurements for the rubber as well, and then you are done with the experiment. So essentially what you're going to learn out of this hardness test is you're going to learn what hardness is, and then you're going to learn how to do a Vickers test for a hardness, to test the hardness of the metals, and you're going to learn how to use a durometer. A statistical analysis is always there, and then you will be done with the test. This is also a very short test, a little longer than what you're going to do this week. It's also a very short test. So I don't think you guys are going to have any issues. Maybe when you create the indentation, you just want to be careful that you really move that module, the indentation module, because if you move it up and down, you won't be able to find your indentation. Right? So you just want to rotate it, make sure it doesn't move up and down. You might have some difficulty there. Any questions? Yes.
Do you want us to also find the standard deviation for this one?
Yeah,
or
you always have to do a statistical analysis.
Always, okay.
Yeah, always. For experimental tests, sometimes you do a numerical test. For experimental tests, you always have to make the measurement many times, not just once. And then you always have to do a statistical analysis, find the standard deviation. In most of the cases, I give you a confidence interval and I ask you to use the student t-test for this confidence interval. But in some cases, you just have to find the standard deviation and give me any confidence interval. Any questions? One before these lectures are very short lectures, as you've noticed, and this is going to be mostly the case for most of the experiments. The bulk of the thing you're going to learn in this class is going to be from the lab, right? There's no point in coming to these lectures and talking about theory and like solving example problems and whatever, right? And so you want to make sure you are very careful in the lab. You try to ask as many questions as possible from the TA. The TAs might not know things, that's all right. Just send me an email and ask me, or just let them come to me and ask me. One thing that I have to mention that this always comes up. Your TAs are also students. Most of them are graduate students, but some of them are undergraduate students, and a lot of them don't really know anything, right? Students, right? And so sometimes you go to the lab and you see that the device, whatever you are trying to use, is not working. Doesn't mean that device is broken. It just means that your TA doesn't know how to use it, which is fine by me if it happens once or twice. This is always the case. You always have to reach out to me and tell me that we are not really learning anything from the lab because the TA doesn't really know anything, right? But if that happens, just ask your TA to send me an email and ask it about the issue, right? Most of the time, like 99% of the time, none of the equipments are broken. They are in working conditions. There's just a mess up somewhere, right? This is something you definitely have to mention. Any questions? So, if you are a mechanical engineering student, who are mechanical engineers in the class again? Who are the aerospace engineers? Okay, yeah. If you're a mechanical engineer, I'll see you next Monday. If you are an aerospace engineer, I'll see you next Wednesday. If you are, there are a couple of mechanical engineers who are, so this essentially for aerospace engineers, in 2 weeks, we're going to use the flight simulators. There are a couple of mechanical engineers who, for some reason, like, I guess these are just fun, so for some reason like to use flight simulators as well. If you are one of those, you're welcome to come to class on Wednesday, and then you can still have time to use the flight simulators. Next week's Wednesday, so in 9 days.
I think I might.
Where do you want it?
Just right there.
Right here? With
Yeah.
a pencil? Of course, I'm gonna.